Hi everyone, we're going to use trigonometry today to help us find missing sides or angles in a right triangle. So we learned about special triangles, 30, 60, 90, 45, 45, 90, and we even learned about some what we call Pythagorean triples. But what happens when you have a triangle where, it's not one of these special triangles and you only have one side and you need to figure out the other two? When we had a 30, 60, 90, if we knew that this side was 5, well, we figured out, that the hypotenuse had to be 10 and the other leg was 5 root 3. But what happens, say, when you have a triangle and the angle is 20 degrees and the side is 5 and you need to figure out the other two? Well, today we're going to talk about trigonometry, and there are special ratios. You notice that in 30, 60, 90s, for example, that the ratio of the side opposite the 30 degrees and the hypotenuse were always in a 1:2 ratio. That ratio where you compare the opposite side to the hypotenuse is called the sine ratio. Okay, so we have sine, cosine, and tangent as three special ratios. The sine ratio is when you look at an angle. Okay, so the sine of an angle, I'm going to use a fancy variable because we're not only talking about in 30 degrees, it could be any angle. So the sine of an angle, I'm going to use theta. Okay, that's just a variable, we're going to use it for the angle. The sine of an angle is the ratio of the opposite side over the hypotenuse. The cosine is another ratio. It's when we compare what's called the adjacent side. Okay, when I say adjacent, it's when we compare the adjacent side to the hypotenuse. And the tangent ratio, so when we look at an angle, it's when we compare the opposite side to the adjacent. Now the reason why I have the angle there is that it's important to know which angle you're talking about when we refer to opposite or adjacent. Because when I look at this 30 degrees, the side that is opposite to it is 5. If I were to look at this 60 degrees, the side that is opposite to that angle is 5 root 3. So it's important for us to know which angle you're referring to when we use the ratio. The sine of 30 degrees, for example, is not the same thing as the sine of 60 degrees, for example. So I told you we could use trigonometry to figure out what would be the hypotenuse in a triangle where, when given an angle, is 20 degrees. Well, I'm going to show you how to do that. Okay, so let's call this x. So if I look at this 20-degree angle, I have to look at the side that I do know and the side that I'm trying to find. When I look at the side that is 5 units, that is the opposite side. When I look at the x, that is my hypotenuse. So right away I know that I'm going to utilize the sine ratio to help me figure out my hypotenuse. So the sine of 20 degrees equals the ratio or the fraction 5 over some number. I don't know that number, so I'm going to refer to it as x. To solve for x, well, I could use proportions to help me. So I'm just going to put sine 20 over 1, and now cross multiply. When I cross multiply, I'm going to get x times the sine of 20 equals 1 times 5, which is 5. Okay, so I cross multiply. Think about it. How would you get x, that variable, by itself? Well, if I divide both sides by the sine of 20, I can get x by itself. Remember, the sine of 20, that's a number. So on my calculator, you guys need your calculators for this. You're going to do 5 divided by the sine of 20. And when I do that, I get x equals 14.6. Okay, now I don't expect you to memorize the ratio, the relationship, in a 20, 70, 90 triangle. Okay, so trigonometry is helpful in that. Now for those who might want to calculate the other side, remember you could always use Pythagorean theorem now that you have two sides of that right triangle. You might have noticed this pattern of the letters at the top I was referring to. So, ka, toa. That helps us memorize the ratios. Let's look at another problem.